Hello AP Calculus. I thought I'd make one last video for the semester to give you a clear expectation of what it means to do 6.1 and 6.2. Rolle's theorem, mean value theorem, and then all that stuff with the motion problems that you guys started working on today. So this might be an extended video, might take a while, so dig in. So the first task is going to be, you're given a function f of x. We are going to verify the hypotheses of Rolle's theorem over the closed interval -3 to 2.5. So here's what Rolle's theorem says. We need to have a function that's both differentiable and continuous over the open interval. Sorry, it needs to be differentiable over the open interval -3 to 2.5, but also continuous over the closed interval -3 to 2.5. Now, right off the bat, we can say that it is continuous because since f of x is a polynomial, it's a continuous function. So we can take care of continuity right off the bat. Now, can we confirm whether or not it's differentiable from both the right and from the left of those endpoints? Well, I think it's not too far of a stretch to say that the derivative of f is 6x squared plus 2x minus 15. Since f prime is a polynomial, it exists everywhere. It exists for all real numbers. Right? The domain of this function is -infinity to infinity, which means if the derivative exists from -infinity to infinity, then the derivative exists from -3 to 2.5. And if the derivative exists, that means it's differentiable at those places. So this function is differentiable everywhere, not just -3 to 2.5. So that explanation confirms that it is differentiable over the interval given. What are the other hypotheses? So let f be differentiable and continuous. We also need the function at a, this is a, to equal the function at b, and they both need to be 0. So here's what we got to do for the last one. Does f of a equal f of b, which equals 0? Question mark. Well, that all you got to do is plug it in. So can you guys see here? I think you can. Yeah. So what does f of a equal? F of -3 is equal to 2 times -3 to the third power plus -3 squared minus 15 times -3. -3 cubed is -27 times 2 is -54. So this is -54 plus 9, which is -45. -15 times -3 is +45. -45 plus 45 is 0. So we know our left endpoint equals 0. Our right endpoint well, this is maybe a wee bit harder to do in my head. Same for you guys. I know this is 37.5. I know this is 6.25. I'm not sure what 2.5 cubed is off the top of my head. So there's no shame at this point in conceding to a calculator. After all, they are helpers. They should not be competitors. We do not derive our self-worth solely from our ability to do computations in our head. 0! So it satisfies the 3 initial conditions. It's got to be differentiable over this open interval. Check. It's differentiable everywhere. It's got to be continuous over this closed interval. Check. It's a polynomial, so it's continuous everywhere. Does the left endpoint equal the right endpoint and both of them equal 0? Yes, yes, and yes. So that's how you verify the hypotheses for Rolle's theorem. Now, part B. Oh no, what are we talking about here? We're still talking about 2x cubed minus 15x. Oh boy, I'm already forgetting. I think it's minus x squared. The wonders of technology. Plus, okay, got it. Over the interval -3 to 2.5. Find all the values of c that satisfies the conclusion. Well, the conclusion the conclusion of Rolle's theorem is that there is at least one point c in between a and b such that the derivative equals 0 there. So, in a nutshell, what it's saying is find there must exist at least one critical number. I will call it affectionate term, Crumbers, that we use. So how do we find Crumbers to verify this existence? Well, we take a derivative. We set it equal to 0. We ask ourselves, where does this potentially equal 0? So I don't know if factoring's our best bet or if we should just go to the quadratic formula. Right off the top of my head, it seems like, I don't know. What multiplies to give us -90 and adds up to give us 2? I'm not sure. Let's try the quadratic formula. -b plus or minus b squared minus 4ac all over 2 times a. So the inside of this would be 4 plus, let's see, 15 times 24 is, I think, 360. Let's just do the whole shebang right now. Yeah, 364. And if memory serves me correctly, 364 is not a perfect square. So I'm just going to run the numbers here. The addition yields 1.432. Scratch that, 1.423. The subtraction yields -1.756. Now, both of those values, these are the c values they're talking about. F prime of c equals 0. At these spots, and they both live in between -3 and 2.5. This is the conclusion of the theorem, that there's going to be a horizontal tangent line at 1.423. There's going to be another horizontal tangent line at x equals -1.7656. All right, so there's Rolle's theorem kind of summarized in this one example. Hopefully that's making more sense to you guys after you watched, I think there was like 5 videos I posted on Google Classroom. All right, number 3. Still frozen. So now we have to do things with the mean value theorem. So the mean value theorem stated pretty much similar hypotheses. The start of the statement, you got to be differentiable, you got to be continuous. But what they're saying, okay, what they're saying is that there's a point in between -2 and 2, such that for our curve, which our curve looks like this, the slope of this line right here, they called it like a secant line, must equal the slope of the tangent line at a certain spot. They're basically saying the point at which there is a point in between -2 and 2 in which the average value of the function equals the instant value of the function. I was explaining this to another student in the class where it's kind of like if somebody determines that, you click on your cruise control and you're going 70 miles an hour on the interstate, and say you're in a certain place where 65 is the speed limit. Well, if somebody got that data and said, you were going an average of 70 miles an hour for an hour-long trip, it was continuous, okay? You broke the law because at some point you were driving 70 miles an hour, which would be over the 65 mile an hour limit. So, sorry, I don't mean to confuse you guys with that example. I might have. But here's the conclusion to the theorem. There exists a value of the derivative, okay? Some number that exists between -2 and 2, that's the C value, such that the average rate of change, which is the exact same thing as sort of like y2 minus y1 over x2 minus x1. This is your slope formula, because this is the slope of a tangent line. It's where the average equals the instantaneous. Average slope equals the instantaneous slope. So what do? You find the derivative. The derivative of f is going to equal 6x squared minus x plus 1. So now it's sort of like, well, if we're talking about this C value that lives between A and B, we kind of have to just say, all right, here's the function as is. This now becomes the left-hand side of this equation. And now you do f of b minus f of a over b minus a. You're going to actually compute this slope in between -2 and 2. So all we got to do is plug in 2 for x. All right, so it's f of 2 minus f of -2, all divided by 2 minus -2, which is 4. Yeah, and if you want to kind of simplify this on your own, you can multiply both sides by 4, which gives you 24c squared minus 4c plus 4. Okay, so I multiplied both sides by 4. And then f of 2 minus f of -2. I'm just going to use my calculator to hopefully expedite this process, make it go a lot quicker. So f of 2 would be 11. F of -2, I'm using a calculator with a table of values. -25. Oh boy. Oh, shoot, I should have just kept the 4 on the bottom, because this is going to be 36. 36 divided by 4 is 9. I messed it up. It's okay. We can still continue. So, in this space right here, I'm going to solve the equation 24c squared minus 4c plus 4 is equal to 36. This will tell us the exact value in which the average value of this function from here equals the instantaneous rate of change of that function. sorry, not average value, average rate of change. All right, so 24c squared minus 4c minus 32 equals 0. I'm going to divide everything by 4 just to make them easier numbers. 6c squared minus 1c minus 8 equals 0. I don't believe this is factorable. I can't think of two numbers that are 1 apart that multiply to give you negative 48. So we have to use the quadratic formula. Negative b plus or minus the square root of b squared, negative 1 squared is 1, minus 4 times 6 times negative 8. That's your 4ac. And then 2 times 6 is going to be 12. So then this equals 1 plus or minus the square root of, let's see, 24 times 8 should be, I think, 192? Let's be sure. All right, so 1 minus 4 times 6 times negative 8. Is it going to be 193? Okay, that's not negative. Sorry, I'm struggling with basic things right now. So 193 is the total underneath the root. Okay, compute it. The two solutions are 1.241 and negative 1.074. They both live in between it, so they both verify. Now here's the thing. What did we actually find? Well, think of this in terms of the speed limit example that I was talking about earlier. It's basically saying at these time values, if this represented your kind of like the path that your car went on, they'd be saying things like, hey, this is the point at which we know you traveled 70 miles an hour. This would work too if it wasn't sort of a negative time. That's kind of a wonky issue with that. But yeah, bottom line is these are instant x. These are x values in which the instantaneous rate of change matches the average rate of change. So this video is pushing 18 minutes. I think we covered everything we needed to on Rolle's theorem and mean value theorem, so I'm going to stop this video and then start again with the next example of this note sheet. So hopefully you guys are finding this semi-helpful, and yeah, thanks for watching.